Alright, we're going to continue this lesson on trigonometry. And we already know now that we have a diameter of a circle here. And the line from point A to point D here is a radius of a circle. The line from point A to point B is the radius of a circle. We already know we have an equilateral triangle. We have a tangent line. If we extend this diameter out, we have a secant line. And that pretty much prepares us for the lesson. Now, let's get into sine, cosine, and tangent. And the first thing we're going to do is we're going to show you this little line right here. It goes from point D to point E. Now, you'll notice that if we were to extend this line all the way up and down, all the way straight across, it would be a secant line. But if you take a look a little more carefully at the shape of this, you have your circle here. This is the circumference of the circle. It passes through point D, and it also passes through this point right down here, and we could call this F if we wanted to, okay? So it's got pass through point D and point F, okay? You got this great big line, and you got this little arc right here. Now, doesn't that look like a bow and arrow? All right. Well, the word sine means bend. Well, don't you bend the string, the bowstring, to shoot your bow and arrow? Well, there you go. All right. Now, originally, the sine of a triangle was this line from point D to point E. That was the sine. However, they've gotten into modern mathematics, so it becomes a ratio. So, what's the ratio here? Well, first of all, you have three sides of an not equilateral, but a right angle triangle here. Okay, you have a right angle triangle, you have three sides. Now, the longest side on a right angle triangle is called the hypotenuse. Okay, and we'll get into that another day. Just trust me, it's called the hypotenuse. Okay, now, we have a side that is adjacent or connected to the hypotenuse, which makes this acute angle. Okay? So this acute angle is formed by the hypotenuse and the line that is connected to the hypotenuse right here, which is the adjacent, this is the adjacent line, which makes the acute angle. Okay? Alright, so you have the hypotenuse here, you have the adjacent side here, and the side that is opposite of this acute angle is right here. Okay? So again, you got the hypotenuse here, the side that's adjacent that makes this acute angle, and the side over here that is opposite of the acute angle. Alright. So, what's mathematical sine? Well, it becomes a ratio. Now, I'm sure you've seen like 5-to-1 ratios. And I could go on and on, 5-to-1, 4-to-6, so on and so forth. What you do, this 5 here is a numerator. This 1 here is a denominator. And so you divide the numerator by the denominator, and this is where fractions come in. And I'm sure you remember all that, and we don't have to go through all that. One of these days I may make a video about ratios, and if I do, you can watch it. Otherwise, you pretty much got the whole thing right down pat. If you watch the fraction video, if you watch the reciprocal video, you pretty much got this whole thing pat down. Okay? So the 5 here in a ratio problem like this is the numerator, the 1 is the denominator, and you're going to divide the numerator by the denominator. Okay? And that's how you basically get percents too. And we'll talk about that another day. Alright, so what's the sine? Well, the sine, if you were to, now, granted, if you're drawing this right angle triangle, you're going to use Euclid's methods. But once Euclid's methods are done, okay, and you've used Euclid's methods to draw what you're trying to draw, then you can start taking measurements. We live in a modern society where there are measurements involved. In Euclid's day, he didn't use measurements, but we here do. Okay, so once you've got your right angle triangle drawn, you can take a measurement, and if you take the measurement of BC and divide it by the measurement of AC, then you'll get the sine of the triangle. Alright, now what is cosine? Well, Cosine comes from the Latin complementi sinus. Now, sinus was the actual Latin word that meant bend, which became sine. Okay? So, what we're trying to do when we're trying to find a cosine is to find the sine of the complement angle. Alright, how do you do that? Well, first of all, you find the measurement of AB, which this is AB right here, which is your adjacent side. And then you're going to find the measurement of AC, which is the hypotenuse. And you're going to divide the measurement of the adjacent side by the measurement of the hypotenuse side, and you'll get the cosine. Okay? Tangent, well, tangent comes from the Latin word to mean touch. Okay? Now, tangent was originally applied to line segment BC. Okay? And BC was the line segment that was cut off by this secant line right here. Okay? So you have point B, point C was found by the cutoff of the secant line, and so therefore originally this was the tangent. But nowadays we've gotten into modern mathematics, and this is a long story and I won't bore you with it, but the way to find modern day tangents is to first take the measurement of BC, which is your tangent line, and then you're going to divide that length by AB. Okay, so the length of this here divided by the length of this here is the tangent. Okay. Then you have your secant. Well, this is your secant line right here. And AD would be a part of that secant line. Okay, so that was originally your secant. And a secant meant to cut. So what you're doing is you're cutting this curve in two different parts. Alright. Now this line actually, in this case, cut off the tangent to the curve if you extend it out far enough. Alright. So, originally the secant line was AC, but in modern day mathematics, it is the measurement of line AC. Okay, secant is the measurement of line AC divided by the measurement of AB. So you take the length of AC divided by the length of AB and you get the secant. Now, if you want the cosecant, which is the complementi secant, alright, what you would do is you'd find the length of AC, which is this, and you would divide it by the length of BC, which is this. AC here, the length here, divided by BC would give you the cosecant. And finally we get to the cotangent, and that's complementi tangent. Alright, so you're going to find the length of AB, which is right here, and you're going to divide it by the length of BC, which is right here, and when you do, you get the cotangent length that you're looking for. And that's the 6 basic ratios of trigonometry. Now, I'll go more in depth with this in a future video, so I want you to stay tuned and have some fun with this.